Hello, Robert Lord from Seed Engineering. I'm presenting on 4 performance-murdering mistakes in kitchen ventilation that consultants keep making. At no time, like ever before, has kitchen staff performance, their ability to think and act and follow instructions, it's never been more critical. Airflow, lighting and comfort need to be much more than compliance. Even when we get spaces like this one, where the ceiling space is only 118 mil, there are still solutions if we can avoid these 4 mistakes that I wish to talk through. When we talk about staff productivity, these are the items that we're talking about: the air quality, the comfort, the acoustic quality, and of course, lighting. These issues are affecting each and every kitchen every day, and they are easy for the designer to work with and to work through. However, there's lots of research being shown that these things are not happening. This set of studies here is just a simple search, and it covers everywhere from London to the US, China, Japan, India, and all of them are showing signs that we are not prepared to deal with the heat stress and the thermal strain that is put on top of kitchen staff, and it is giving the staff problems with difficulty with fatigue and exhaustion. These are the 4 mistakes that we commonly see with conventional design. Firstly, the designer is not looking at the heat load of the equipment underneath the hood. They are following the compliance air quantities, and whilst that's often okay, it is also, say 10% of the time, it is not okay, and chefs are getting overheated in the workplace. Secondly, there is a limited understanding of breach control. The presumption is that the hood design by AS 1668 Part 2 is sufficient to maintain breach. That is not true. The third issue is that there's no thought to acoustic treatment. For a long time, acoustics in kitchen ventilation has been very difficult to provide a duct that is able to absorb sound and also to control the sound levels. That is no longer the case with modern materials and technology. And finally, there is no assessment or regard for thermal comfort. What the chefs are wearing, the activity levels they're going through, the actual air and humidity environment that they're working in. These 4 mistakes are robbing your talented staff of being able to perform in the modern kitchen. This here is the German formula for determining kitchen exhaust air quantities. I want to highlight to you that it has a focus on the height of the hood above the equipment. So the closer the hood is, then obviously the lower the air quantities that are required. It has a thing called the convective heat flow, which is determined by working out what is the power of the energy that's being put into this flow. There is an installation factor, so this is things like whether you have an island hood or a wall hood. And finally, there are technologies that the hood suppliers may supply which improve the hood efficiency. The key thing I want to draw your attention to is that the power input, this convective heat flow, is responsible for driving this thermic airflow. This thermic airflow occurs no matter what you do. And I also wish to draw your attention to these angles. The German standard sees the angle of this line from the vertical as 15 degrees, and therefore hood overlaps that are greater than that are possibly unnecessary and would reflect a poor hood design. So we call this breach control, and what we're seeing here is an example where steps have been taken to improve breach control. One of them is that the edge at the back of the hood has been lowered so that the proximity of the height of the hood above the cooking equipment is lower. Another one is this curved face. So this comes from a particular supplier, but other suppliers also have terrific measures such as CaptureJet technology from Halton to being able to control and manage breach control. Another item is acoustic comfort. When you take the German formula that relies on heat, and when you turn down your kitchens in the evening, then you can see that you don't need as much air. This sort of a system up here, if you look in this corner, is scanning the ventilation systems for heat as well as for smoke or visibility. And that's telling this controller here that it can accelerate or slow down the exhaust fans and therefore the supply fans. If you were to go from 100% speed down to just even 30% speed, you will find that the sound level within the kitchen will drop by 8 dBA, which is quite significant. There's also, I guess, a reluctance from consultants to specify the correct type of insulation. It needn't have a perforated face, which is what most consultants are used to. You can get sealed insulation that has great acoustic properties, and you simply need to specify this style of duct insulation. Another way to provide thermal comfort, as I've said, is via these local air movement systems. This here is an image from Halton, where they provide a chef comfort adjustment for airflow. But the other way to provide comfort is simply through the transfer air. We often need to provide lots of outside air for the seated dining areas, and that provides a surplus of air which has got nowhere to go except to head towards the kitchen. It's this transfer air that provides the cooling for the chef. Of course, we need to be a little bit careful about this air supply that comes from over here, that it doesn't disrupt gas flames, because that will upset chef. However, you can find systems that combine all of these aspects together. So when we come to do heat loads, we are looking to understand what is the heat of the equipment and just how hot is it. This is a particularly warm kitchen. The air is going to be discharging at 65 degrees. But if we look at the radiation calculations, you can see here that by simply providing a 1200 millimeter gap from for the aisle, we can have a very low MET. If we reduce that to 900, it is a very high MET. MET stands for the amount of heat that you need to deal with, and we should be below 2 for our chefs to be comfortable and to avoid heat stress. Finally, you will find that there are systems where you should test heat flow patterns. In this particular test, we've actually got breach, or it appears to have breach, and then the hood airflow pattern brings this all back. But what's going on here is that the supply air pattern is not affecting down at the low level, like not affecting the gas flame, but it's able to control how breach is maintained. And that is this curved face. This curved face is also useful for being able to slow down the hoods and still provide breach control. If you wish to know more, there's a much more technical report. We don't recommend any particular brands. We just recommend good engineering. This report will show you how to avoid mistakes in your next kitchen ventilation project. The trick is to focus on staff well-being. Those sorts of kitchens are easier to clean and more profitable for the operator.